This nebula's stars are literally being ripped apart. Wait, what? But also, this nebula is 35 light years across and has an apparent magnitude of about 7.7. But that's not all. The nebula in question is C9. To start, we have two types of images. The left shows the original image captured by the C-Star S50 telescope, meaning that we get to see all the noise, background filter, but also the original detail kept in this image. C-Star also has a feature called AI denoise, using AI to remove noise and to filler from images. Now, AI sounds annoying, but the AI is one of the good AI models. In this case, the AI has managed to remove a star trail. Besides that, most of the difference is not adding more detail, but refining the original image, removing some of that noise that was blocking us from seeing certain parts of C9. By the way, C9 is also called the Cave Nebula, along with a classification SH2-155. This is the most common classification, so I'll just be calling it SH2-155 or just the nebula. Oh, and for the actual images, lots of stars are noticed, along with a bigger yellow object to the right, which I believe is just a star. It might be a cluster. The nebula is faintly hidden in the center image. You have to zoom in. Zoom in? Zoom in some more. Nope, even more. Finally. You see it right there? And yeah. Now, this nebula has very little data, which we're going to get to. But all we know is that the distance is 0.8 to 0.88 kiloparsecs, 2,600 to 2,800 light years, and is moving towards us at 14 kilometers per second. The RA is 22 hours, 57 minutes, 17.4 seconds, and the declination is 62 degrees, 28 arc minutes, and 33.4 arc seconds. Its apparent magnitude is like 7.7, but only 16 for the absolute magnitude. That's another thing we're going to investigate. Oh yeah, it's 35 light years in radius. By the way, for this video, it's mostly like a bunch of mini mysteries. So, a couple of mysteries. 1, why does this object have such little data? And 2, why is the absolute magnitude so different than the apparent magnitude? 3, what did I mean earlier in this video with stars ripping their disks apart? Well, these kind of all have to do with each other. The first mystery is why this object has such little data. Now, remember that video I made recently about the star 13 Mon? The big mystery of that video was basically that 13 Mon has like a weird distance measurement. Some sources said like 1,500 light years, while others went all the way up to like 4,000 light years, which is like a huge difference. A lot of the reasons that have to do with that star's weird distance measurements also apply to this nebula. In particular, it's mostly just because the nebula is so dim, the surface temperature. Here's the thing, the surface brightness. It's so spread out, 35 light years. So even though there are a lot of stars, in fact there's 2 star clusters, the nebula is so big that most of that brightness spreads across the surface like a lot. So the brightness on the surface of the nebula is very low. So even if it was only like 30 light years away from us, this nebula will be super duper dim. Another thing is why is there such little data? That has to do with the brightness. Also, the region's in hydrogen ionized area, so basically there's like a bunch of ionizing radiation. So it's pretty hard to figure out, data about this nebula. But why? Because of this one star, HD 217086. It's the star inside the nebula that does a lot of things. It ionized the entire region. It caused a bunch of star formation. And most importantly, because of its central role, when stars get closer to the O-type star, their disks actually get ripped off, which causes a very bad disk to non-disk ratio of like 40 to 100. Normally it should be like 80 to 20. Plus, there's over 400 stars in this general region that emit X-rays. Alright, and this nebula is technically an emission nebula. It emits its own light from HD 217086. And it's also a reflection nebula because it reflects the light of other hot blue stars in the area as well. And its dark dust regions give it the dark nebula. A dark nebula is just a nebula with no light whatsoever, just gas. So, in conclusion, basically, this one star made like the entire nebula region change. Alright, here's a figure to show what I mean from this one research paper. So you can see here the red is no disks, blue is disks. As you get closer to the main star, which is highlighted in a blue box, you can see the disks start to get outweighed by the non-disk stars. Whereas if you go further away, you see, more disks than non-disks. Plus, younger stars tend to be closer to the core of the nebula, whereas older stars go a little bit towards the edges. And yeah, it's pretty crazy that this one star can make such a big difference, as you can see in this figure 11 that I showed. Now you might be wondering, why are my videos been all about stars? Well, in truth, a lot of things that cause these nebulas and planets and all that to be affected is stars, because there's so many stars in the Milky Way that a few of them are bound to do some crazy stuff. So a lot of things kind of just do boil down to stars. Oh, and did you notice the background was changing? Maybe not, maybe yes. Have a great day.